Here is my name. My name is Zheng Xinwang. I'm a professor in Computer Science Technology Department, and I'm IHV senior member. So if you have a question, you can email to my address. My email address is design@ieee.org. Our course objective is to teach the practical developing skills to students. So after this course, students can design several simple products. All these products are based on ARM processor. Although there are other choices, for example, FPGA, CPUD, but in this course, this is the first section. In this course, we will only emphasize on ARM processor. And then the students can learn the procedure of research and development. This is a practical research and development example. Here we have a lot of contract, so a technical contract. So I get this from practical project to teach you, to act as a teaching material. And then learner can grasp those software tools and assist the development. For example, KMGK software, Ultimate Design software. All these software are essential to our development. Other software include multi-sim simulator, Produce simulator. Multi-sim is used to simulate analogous circuit, while Produce is always used to simulate a single chip microprocessor. For example, STM32. And then students can design the technical solution according to the requirement. For example, if a company asks you to develop a new innovation product, so you can negotiate with those technical requirements. Then, after understand fully about the technical, after understand the detail of the technical requirement, then you can design, give them design solution, and report the price of the design. Because the design price is intimately related with the detail of the design. So for example, some design is very simple. So maybe take about 2 weeks, 3 weeks you can finish. However, some is more complex. Even some project seems not very complex. You still need to find some key points which will generate some risk in the project. So that is very necessary. Then students can grasp. This is the core concept, core technology of what we will learn, schematic design. After successfully design the schematic, we will design PCB board. And after PCB board is designed, we will manufacture. I will teach you how to manufacture online, submit this PCB board to ERP system online. And then after you successfully submit, after pay, I just emulate, not actually pay. After you pay the manufacturing fee, then the factory can finish those SMT process within 1 week and ship it back. Then you can, after you have received those piece of PCB board, then you can debug then you can programming debug, and maybe you find there are some drawbacks on the schematic. Maybe some wire is disconnect or connect the wrong direction. You can revise. So this is a kind of iteration process. In general, we will, for each product, we will revise 2 or 3 times. For some special product, the custom will testing for a very long time. And some custom are just testing by themselves and then sell to the customer, sell to their own customer. And those custom are running, those devices are running on the factory, or running on other place. After some period, for example, 1 year, or sometimes several months, there's some problem generation. So after they give feedback, the engineer needed to revise this code or find some bugs inside the software programming to make it satisfy the requirement of machine's smooth running. Another purpose is to understand the interface and the corresponding application. Different application need a different interface. For example, remote control or remote monitoring system in chemical factory, they need to pull the information with CAN bus. So by CAN bus, they can. This is a special interface which is in the past used on the car factory, and now is also used in industrial controller. Another example is the RS485 interface. This is a traditional interface which used in factory. Other interfaces include, for example, in current years, we use Internet of Things. So we use serial port to connect to a module. The module is just a kind of 4G module, sometimes IoT module. So use the serial port, the processor connect first with the module, and then the module connect to the tower, then to the cloud. So this is interface. Different product, they need a different interface. The mostly common used interface is I2C, SPI interface, serial port, port. These are very common interface. Okay, and then the 7, you will understand how to create a product through reverse engineering. Reverse engineering is very important in recent years. I have a lot of customers. Maybe 70% of the customers, they need reverse engineering. Because those, 你叫我静音了，不对了。对，我这要那个处理一下，不对了，你不要去动了。
打开吗？
我解除。好了，可以。我共享屏幕正常的是吧？OK。
屏幕没共享，
我刚才一直没共享屏幕啊？啊？
对。
那我重来共享一下。我搞了半天没共享屏幕啊。OK， 现在可以看到了吧？
可以看到。
啊 ，OK。And maybe 70% of my custom, they need reverse engineering because those product buy from Western country is very expensive. So these factory in the past, these custom are agency. They sell this foreign product. However, after they sell some time, they find they can make it by themselves. So they find them to tell me that they want to product by themselves. So I told them reverse engineering. I just needed to learn the function of the machine and then propose my own solutions. Use CPU, what you're familiar with, to redesign the product. I'm not saying it's copycat. Copycat is illegal in the market. So I'm not saying copycat. I just say reverse engineering. So reverse engineering is nothing to do with copycat. Copycat have also another kind of drawback is that you cannot change any function of the original machine or original device. However, if you redesign this device, you can add extra function. You can add some innovation idea to the foreign imported device and make it more strong than ever. So your price can, your sale price can increase dramatically later, not in the beginning, but later, I say. So through this course, you can grasp some basic techniques of the developing embedded system product, and you can have the ability to make those innovation ideas into reality. So before I introduce embedded system, I also needed to emphasize on about the market requirement of the embedded system. Requirement of the embedded system is increased from about 2010, before 2010. So at about 2000 years, there are some very rare ARM processor, ARM developing board appear on the market. And later, with the time passing, many ARM processors are emerged. Now, what the market requires, we can divide into several domains. One domain is consumer electronic device. For example, I have some custom, they sell those oxygen generator machine to other countries. This is, I think, is belong to consumer electronic, because some people, their health is not very good. They need to breathe oxygen, so the factory produce this kind of machine and sell to them. Another, some healthy device for human being, like a foot massage machine, some eye massage machine. This is also belong to consumer electronics. Another is everyone know, like a refrigerator, like a air conditioning. These are all belong to consumer. Another is that industrial controller. Industrial controller is different with consumer electronic device. So the design concept, the design idea is very, very different. Although the core concept is always the same, but the design method is different. What you think, what your choice is different. So industrial controller is more emphasis on stability. No factory like those device unstable. So stability and high precision is what the industrial controller want. Another category is that instrument. For example, scientific detection instrument. This is also another kind of device. there are a lot of sensors on this kind of device. Sometimes there are some complex algorithm embedded in this device. The fourth kind of category is that medical device. In these years, always a lot of customers, they want to design medical device. So medical device is different with other category because safety is the most important. So they have very high standard requirement about the medical device. Okay. Also, in recent 2 or 3 years, vehicle device, electronic vehicle device is emerging. And a lot of customers I found they want to design, for example, CAN-based controller. Some EPB, electronic parking brake, these are also belong to vehicle device. Some, like in a big factory in Shanghai, SAIT, they want to design a sensor device. They want to design a sensor device which utilize sensor to detect hydrogen, leakage of the hydrogen. So this is also belong to vehicle device. But currently, the students who learn in embedded system or computer hardware, there are a lot of problems. The company want those students can work directly. However, these students are unable to fulfill the requirement of this company. So students, on one side, students cannot match the requirement of the company. On the other side, company want a kind of high standard, high level students who is qualified for this project. So those company can't have the opportunity, enough opportunity to get this kind of engineer. And the students also haven't too much choice to find a company who can work because he is not qualified for the requirement of the company. So there's a big gap between the students and the company. The problem is that the students learned in school is almost completely unrelated with the current company requirement. Only those knowledge which is outdated, which is separated, which is isolated. So how to merge different parts of knowledge together is very important. In this course, we will learn how to merge the whole process from the beginning of a product to the end of manufacture. Every step you should be familiar. So how to solve this kind of problem? I suggest you can do as you learn. Some students want to learn enough basic technology, knowledge of this domain, and then begin to design. I told them it's impossible because if you learn at the same time you just experiment, just doing, just design, you can have enough self-confidence. You have enough interesting. Otherwise, too much frustrate, you will give up. So this is very important. So we have to grasp this kind of design step by step from simple to complex. I know during this period, you will endure a lot of failure. You will feel upset, unpleasure, because always fail. But as you know, fail is the mother of success. So it's inevitable to fail. Fail is an essential part of our learning. After you overcome several fails, many hundreds fails, then you will become an expert in this domain. Okay. Then we will teach what is embedded system. This definition is adapted from Wiki. So after I introduce the definition, I will illustrate this concept with some picture. An embedded system is a computer system. First, it is a computer system. It is a combination of computer processor. So this is necessary part, computer processor. Then computer memory. If you haven't memory, the computer cannot run it. And input-output peripherals device. Then all these devices are dedicated within a target machine or electronic system. It's embedded as a part of a complete device, often include electrical or electronic hardware and mechanical parts. So because an embedded system typically controls physical operation of the machine that is embedded within, it often has a real-time computing constraints. So real-time is very, very important in the embedded system. Okay, let's explain this kind of. First, this is a machine. I designed this machine for my customer. And this is a riveter machine. The controller is an embedded system. This PCB board is installed inside this iron box, inside this box. So here is the CPU, central processor unit. We also call it a processor. And the memory is also inside, integrated inside. Nowadays, all these ARM processors are integrated this flash memory, SDRAM or SRAM inside its body. So it's combined the CPU, memory, flash, and peripherals inside. Then there are some electronic part, like relay. Here's a relay. Here's the RS serial port chip. Here's OPTO, optical. Here's a power module. So referenced to this definition, it has dedicated function within a target machine or electronic system. It's embedded as a part of a computer device, include electronic hardware, and the mechanical part. So here is the mechanical part. Here is LCD. LCD is running Android. So the Android can communicate remotely, use Wi-Fi. So this kind of innovation device, after the material have used up, they can shop online. Then the back end, the cloud server can receive this requirement, and if they pay the money, then ship those material to the factory. So this is a completely new concept of design in modern machine. So what is embedded system emphasized? First, it's application-oriented. The goal of the embedded system is to meet the specific needs of users. For example, the goal of this PCB board is only to fill the requirement of rivet machine. So different embedded system have a kind of characteristic. Different custom have different requirement. So different machine, you need to, at the time you design, you must understand the whole process of the machine. It's impossible you design a device not familiar with the machine. So every time, if a new machine comes, before I assign the new contract, I will go to the factory, go to the field to investigate, to understand how the machine running, the whole environment, the whole function you should familiar. Then after you're familiar with this function, you should give your solution, negotiate with the customer, present your solution. Because what you design, you should fulfill the requirement of the customer. This is very, very important. Customer want what you design can satisfied with their requirement. You cannot design a device not completely, not what the customer want. Otherwise, this is a failed project. Okay. The second is specifically. Most applications of embedded systems have high requirement for reliability and real time, which determines that a dedicated system serving specific application. So, just as I mentioned earlier, the special machine have a special requirement, special function. Okay, and then is software and hardware can be customized. Unlike our desktop, running Windows, everything almost. Embedded systems are targeted at so many application scenarios. Different application scenarios, you should have different hardware and software adaptation, and bring about different requirement. For example, include functional performance, reliability, cost, power consumption. For power consumption is very important in battery limit. In some places, only use battery. For example, Internet of Things installed remotely in rural place, so power consumption is very important. Some device need to keep running 3 years, 5 years. So you must consider power consumption. Another is cost. If I design a foot massage, if you pay the cost is $100, no one will buy it. So the cost is very important. You should invest the current sale of the product. You should invest the intermediate agency, their price, sale price. And then you can find a cost which is fit yourself. You can still have enough profit. Although sometimes the number of selling is not very good, but you still need to balance the cost and the sales number. And the reliability. In industry controller, reliability is very important, but the cost is also very important. Sometimes you have to make a trade-off between cost and reliability, especially in consumer device. So it's difficult to have a set of solutions to meet all system requirements in reality. You have to learn some trade-off, keep some balance. next, let's introduce the history of development. In the past, the real development of embedded computer after the 1970s. It's a kind of 8-bit processor, later 16-bit microprocessor. Then, for example, MCS 51, MCS 8090, 51, MCS 51 is 8-bit microprocessor. MCS 8090 is a 16-bit microprocessor. So the system, the system based on this microprocessor are widely used in many instruments, medical device, robot, home application, and other fields. Even nowadays, you can find a lot of devices still use MCS 51 because those engineer who is aged engineer, they only know how to develop MCS 51 because it's simple. The wider application of microprocessor has formed a broad embedded application market. So the computer manufacturer began to provide OEM product in a large number of plugins to users. Those users are select different CPU board, memory board, and I/O plug-in board. So this kind of arrangement is out of date in the past. They are forming a dedicated embedded computer system and embedded in their own system. Nowadays, no one like this kind of device. As I know, at about before 1990s, manufacturers use this kind of solution, but later this is abandoned. This kind of solution is abandoned. Then in 1980s, with the improvement of microelectronic technology, those manufacturers, integrated circuit manufacturer began to integrate all the microprocessor, those I/O interface, AD converter, DA converter, serial interface, such as ROM, RAM. What is RAM? Random access memory. What is ROM? Read-only memory. In the past, ROM can only write once. RAM can access many times. ROM can only once. ROM, you can understand ROM as hard disk in your computer. RAM is like DDR, SDRAM, but it's different. RAM is static. Here is referred to static. In the past, static RAM, but nowadays we use dynamic RAM, DDR, DDR2, DDR3, DDR4. So in the advanced course of this training, I will teach those learn how to lay out 6-layer PCB board and how to lay out high-speed DDR with most advanced central process unit, CPU. So those learners can learn how to design a mobile phone. Mobile phone is not very complex. Then creating an I/O-oriented microcontroller. So it's commonly known as monolithic processor because its function is very simple. Sometimes also called a single-chip computer. So this is very popular in 1990s, 1980s. In that time, Z80 is very popular. In 1990s, because with the huge demand of this distributed control, flexible manufacturing, digital communication, and information application, the embedded system developed very rapidly. I remember in about 1995 to 2000, in that period, the embedded system application is developed very quickly in China. And then DSP, what is DSP? DSP means digital signal processor. This kind of product, DSP is different with single chip microcomputer. DSP is always process those signals, especially to video, audio, Fourier transform. They use DSP. So DSP is for real-time signal processing algorithm. High speed, high precision, and low power consumption. The most dominant processor in that time is TMS 320, which is produced by TI company. In the 21st century, the network emerged. So later, the embedded system are combined with the network function. At the first period of this century, some RJ45 socket is installed on the PCB board. And later, this have always disappeared. In nowadays, it's almost disappeared. A lot of embedded system. They add Wi-Fi, they add Bluetooth, they add NB-IoT, they add LTE Cat 1. So these are belong to Internet of Things, also network, but it's Internet of Things. Three stages have undergone. The development of embedded system have generally undergo 3 stages. The first stage is embedded system exists as a programmer controller within a simple function or dedicated computer or single chip computer as core, and has a function to monitoring, server, device indication, and so on. It's mostly used in various types of industrial control, aircraft, missile, and other weapon and equipment. So it's very simple, only have some special function. And then the stage 2, marked by high-end embedded CPU and embedded operation system. The main feature of this phase of the system is that the compute hardware appear higher, reliable, low power consumption embedded CPU, such as ARM, PowerPC. In the past, we use, for example, in this stage, AVR, single processor, and MCS 51, and some Z80. But nowadays, we adopt ARM. ARM is more complex than the single chip microcomputer. ARM also supports operation system. So later, you will learn how to integrate real-time operating system, for example, FreeRTOS, into our embedded system. And support the development and the operation of complex application. Based on this kind of operation system, we can design, for example, graphical interface, install a LCD which touch screen, then programming those GUI application based on middleware, based on graphic middleware. All these kind of software are running on embedded on ARM processor. Then stage 3 is marked by chip technology and internet technology. With the rapid development of microelectronic technology, SoC market makes embedded system smaller and smaller, but its functions are stronger and stronger. Right now, most embedded systems are isolated from internet, but development of internet and increasing close integration of internet technology with the information application, industry control technology. So embedded technology is entering a period of rapid development and wider application. So nowadays, as I introduced earlier, how to combine the cloud with your embedded system, how to combine the edge computing. Edge computing, sometimes, for example, deep learning, which is those code is running on the server side. And in the front end, you detect those, you install a lot of sensors and detect those environment and send these data through the network, wireless network or other kind of network to cloud. And then cloud running deep learning algorithm. And then they will send back this result. After the device receives the result, it will drive the actuator to make it do some action. As we know, almost every electronic device includes an embedded system. You can see this is a refrigerator. It includes an intelligent controller. Detect the temperature inside the refrigerator. You set the temperature, for example, -5 below 0, and the controller have received this configuration. And then it will drive the relay and control the refrigerator motor. After the temperature have decreased to -5, it will stop running. Then after increased some gap, for example, increased to about -4, then it will run again, then keep drop to -5. So it's running periodically. Air conditioning is running in the same way. Like here, air conditioning, it have a PCB board. It will receive the temperature. It will drive the fan inside this plastic shell. It will receive the infrared signal from remote controller. So all these signals, the processor should know how to process this kind of signal. So we will learn how to program, how to design the hardware, how to process this kind of signal. The example is stove, electronic stove. Inside, you can see this is keyboard. So the process must get the information from keyboard. And the business logic will process those configuration data. And even in the end, it will drive the coins inside this shell. Here you can see this is a PCB board inside the refrigerator. Here is CPU, central process unit. 文杰下译了，我这个不是下译了吗？啊，看到了吗？
大概是。
啊？
我的卡说你这个。
Here is the processor. This processor will gather the information, gather the sensor, read the sensor data. First, these sensor data are processed by some analog circuit, and then the analog circuit change the signal to digital format, like AD converter, DA converter. DA converter is
recording stopped.
DA converter is change the signal from CPU
Recording in progress.
and then convert the digital format to analog type. So we will also learn how to process digital to signal from digital to analog, and also how to sample data from analog to digital. This is a very simple product. In general, if you are an engineer who design this kind of PCB board in China, you can only earn about 6,000 RMB, about less than 1,000 US dollar, about 1,000 US dollar your salary. But if you design some complex device, you can got about 20,000 RMB, about 3,000 US dollar. So it's very different. And near this central process unit, you can see there are some switch, a power switch. This is a kind of DC, AC to DC switch. So it will convert the AC power, such as in China, we are 220 volt AC power, AC volt to DC volt. DC volt only 5 volt. So convert from AC to DC. And then there are some inductor to reduce EMI interface. So this is a very, here is some simple sensor. So some resistor or some capacitor. So it's a very simple PCB board, not complex. Here's another device, PCB board, induction cooker, just as I illustrated before. Here's induction cooker. Induction cooker. In here you can see this is a single chip microcomputer. This is a beep. If it have finished the cooking, it will beep. This is a AC to DC switch. So power converter is very important in our design, especially in electronic embedded device. Power switch also. Each time we will use power switch. Some are AC to DC. Sometimes we use DC to DC. Sometimes we will boost the voltage from, for example, 5 volt to 15 volt or to 12 volt. Sometimes from 12 volt to 5 volt. Here is an inductor. Here is a MOS FET. So we will learn later. This is also a picture of embedded system. Here is the central processor. Here is some analog meter, analog resistor. You can adjust the resistor. Here is some relay. Here are some peripheral interface chips. And here is a socket. According to different requirement, you can design different kind of socket. Here is the power part. Like these are MOSFET transistor. These are big capacitor. Why use capacitor? We will learn later. capacitor is like a pool to stabilize those voltage, to remove those ripples of the some small ripples above the voltage. Like here is a couple, optical couple. Here are inductor. These kind of inductor are used to eliminate those common voltage. Okay, so each time you see this kind of PCB board, you will know. Although I no one tell you what is used for, you can have some glimpse and know. Oh, you can guess out what it's doing. For example, this is some relay just to maybe switch on, switch off some motor or some other device. Here is just import. So the power are inserted in this place, and this power function will process, convert the AC high voltage to lower DC voltage. This kind of some chips. So after you have learned enough material, you can know generally know the function. Here the smart meter also use embedded system. Here the LCD, then antenna. So after you see, LCD antenna, this is a kind of Internet of Things. It sample the voltage, the current, and calculate the watt inside this PCB board, and also drive the LCD port, LCD device, LCD module, and calculate some business logic inside. CPU inside the program calculate some business logic, calculate different parameters, and send to the cloud. This is also a kind of meter. It's a water meter. It's similar with this kind of. Here is electrical meter. Here is a water meter. So you can calculate how many water you have used. This is IC card intelligent water meter. In our university, the students go to bathroom, they should pay money. Then their students, they have IC card insert this kind of device. Maybe, for example, 30 minutes they can wash. After 30 minutes, it will stop. So in the screen, it will display how many time left. So inside the microprocessor, they have a timer. The timer is running. After you insert the SD card, IC card, the timer become running. So your software should program the timer. How to program the timer? Make timer running in the interrupt mode. There are different kind of running mode. Some are interrupt-based mode. Some are just running on the main routine. It's different. If you make your code running on the main critical code, time-related critical code running on the main routine, it's not good enough. You must place this time-limited code section on the interrupt routine. This is everyone to test the blood pressure. So it have a sensor embedded inside this. And then the sensor send a signal to the PCB board. And the PCB board also installed LCD. there are different kind of LCD. For such as this kind of LCD, how to design? I can design. I can teach you how to design. You first write the function of this, where I place the segment on which place. You arrange the icon, arrange the digital, and then after all this finished, you submit this design requirement to LCD factory. Then LCD factory will design, they will process your material and design the LCD module for you. In general, the design fee about this kind of LCD is about 4,000 RMB. It's very cheap. 4,000 about 600 US dollar. So they can give you 2 pieces or 3 pieces. It's a sample fee. If you manufacture this kind of device, the LCD, I guess, is about 10 RMB. 10 RMB is less than $2. You can evaluate maybe average $2. So the cost of LCD is only $2. So to this kind of device, cost is very important. So you must control the cost of every component. You should select the component properly to keep the whole cost under your limit. This is a domestic oxygen generator used in home. So oxygen generator inside is, if you take the apart, it's very simple. It's to have 2, we just say the PCB board, because they also have some mechanical part. The PCB board is, first is LCD, and then the oxygen sensor, and then the relay to control the motor. Yeah, this is a crimping machine. Crimping machine, my custom manufacture crimping machine. In the past, they use older device. For example, in this kind of device is very old. They haven't a processor. They are controlled based on relay. Later, they designed computer-based, Android-based new device. So right now, their custom have buy a lot of this kind of machine. As a similar factory, they haven't this kind of function. Their sales are drops. His sales are increased. So how to compete with these rivals is very important. You must have some dominant part to compete with competition with those rivals. This is X-ray fluorescence spectrum. In this example, we also installed ARM processor. ARM processor will gather those sample data from sensor. In front of this sensor, installed a sensor which receive signal. First X-ray shot to the material, and the material bounced back the X-ray, and then it will receive the voltage and the quantity of those X particles, and after gather enough signals, it will display all this data on the screen. So this is also used in embedded system. Another latest, this is latest product. This is electronic welding machine. My custom they just manufacture this kind of these PCB board are take apart from the welding machine, electrical welding machine. These PCB boards originally are designed in West country. Later, a lot of Chinese country also produced it. However, they don't know inside the mechanism how it works. So they want to replace these PCB board by themselves. They want to design. So they ask me. Then you have nothing. At the first time, initially, I have nothing. How I can know the working mechanism of this different PCB board? So you should analyze according to different scenario. In this scenario, first replace this keyboard. Custom said, I will first replace keyboard. After this success, then another contractor replaces this central board, and then later replace this. So I told him, if you want to replace, you should take the machine to my office. Then I use this kind of device. This is very important. This is a logic analyzer. I connect the logic analyzer to serial port of this keyboard, display and keyboard, and analyze the communication signals, and later find the pattern of communication. And then you should analyze the pattern, and you should draft your own communication structure according to original and analyze the data. So you can analyze why, when you, for example, you put this button, which bit will change. So after you have analyzed all these kind of logical signals, you can design a completely brand new, colorful LCD, not just outdated segment display. This is completely rubbish. Embedded system have 4 types. First type is microprocessor unit, MPU. And the second is microcontroller unit, MCU. And then embedded digital signal processor, EDSP. And then embedded system on chip, SoC. SoC is, if you're familiar with FPGA or CPO, this is SoC.
这个很不懂啊，这个不懂，
什么不懂啊？
这个太复杂了。
没关系，我先念一下，念到那个结束。In November 1970s, Intel Corporation launched the world's first microprocessor. This is a 4-bit word-long microchip. The current embedded microprocessor is evolved from the CPU of general-purpose computer. It is a processor with more than 32 bits. So right now, our ARM processor is 32-bit, commonly 32-bit. Compared with the industrial control computer, embedded microprocessor has an advantage of small size, very small, like your nail. Small size, lightweight, low cost. How much money for a processor? I can tell you, some only 1 RMB, maybe 0.2 US dollar, very cheap. And higher reliability. There are also embedded microprocessor development from general purpose microprocessor. For example, in the past, this processor 386 is very popular in the past. This is developed from 386 in especially this is a very popular in 1990s. In the past, the main type of embedded processor are like this. All these are very famous. This is produced by Motorola. Another is MIPS and ARM. Armstrong. Armstrong is you can't hear Armstrong nowadays, but about 15 years ago, always hear about Armstrong. Right now, we never use Armstrong, strong ARM. So right now, ARM-based microprocessor is occupied 90% of the smartphone microprocessor market. Then MCU. Early microcontroller unit integrates various necessary components of a computer into a chip to realize embedded application. So it's also called a single chip microcomputer. So about before ARM processor emerged, all the engineers are familiar with single chip microcomputer. Controller is an integrated circuit chip. So it's the host of a microcomputer. Compared with the microcomputer, single chip computer only lacks I/O device. So some single chip microcomputer lack this kind of device. What is I/O? For example, serial port, parallel port. Compared with embedded microprocessor, the biggest feature of controller is the monolithic. However, the volume greatly reduced. The size is very small. Because the size is small, the power consumption is small. Like the processor inside the mobile phone, it's very small. And improving reliability, because size is small, so electronic interface is very hard to interfere with inside the circuit. It's very small. Microcontrollers are suitable for real-time control. For example, those device, electronic elevator, it's a real-time control. If we have some emergency event, it will stop immediately. So it's real-time. So they are called microcontroller. MCU has the most varieties. For example, the typical MCU, this is most important, 8051, most important in the past. Nowadays, it's outdated. MCS 96 series, it's a 16-bit microcontroller. And C166, this is developed on the CC Studio. So most microcontroller, they support I2C bus, CAN bus, LCD, and many special MCUs and compatible series. Right now, MCU accounts for about 70% of embedded system market. Then DSP. DSP is especially used for signal processing because its internal structure, it's running very fast. If you do floating point calculation, if you do some matrix multiplication, it's very, very fast. It's almost running in parallel. If you use ARM processor, it's running in serial. But if you use JSP, it's running in parallel. So matrix algorithm is very fast if you adopt JSP. It also have high compilation efficiency and instruction execution speed. It also can process discrete time signals very quickly. So, for example, FFT, fast FFT, if it running on JSP, it's very, very quick. Many hundreds, many thousands, sometimes thousands faster than ARM processor. So JSP have widely used in audio and video communication, digital filtering, FFT, spectrum analysis, spectrum like X-ray spectrum use JSP, and other instruments. The most famous JSP not outdated, most famous is TMS 320. This TMS 320 series is very famous. And Motorola, right now Motorola is not famous. And the Semicon, Siemens. Then the embedded SoC. What is SoC? It's a system on chip. This means that is a product and integrated circuit with special purpose. It's complete. It's contain a complete system and all the contents of the embedded software. You can think here is a kind of example. If the central process unit is the brain, SoC is a system that includes the brain, heart, eye, handles. So almost everything is inside. This is SoC. SoC can reduce the area occupied by a system. Sometimes our PCB board is very small, not a big PCB board, maybe only such big PCB board. If a PCB board inside many function, so very small size. So first is small size, and then improve the performance and the robustness of the system. The performance right now, STM32, it can running on 400 megahertz. The latest STM32 almost near 800 megahertz. But for those chips like rock chips made in China, it's running almost 2 gigahertz, very, very fast. You know, STM32 is mainly used in industrial controller, but like those Samsung, like those other rock chips, they are running on the iPad, or some mobile phone, some video processor. Their frequency is much higher than STM32. However, because it's very high, so it's not always used in industrial controller. In industrial controller, we always use a bit lower speed to make the device more stable. So like STM32 is also SoC. In this class, or in this course, we will learn STM32. We will adopt STM32 to design different product. So STM32 is a chip with various ARM cores. No. Chip with various ARM cores. Some STM2 is F1, F2, F3, F4. It's belong to Cortex M0, Cortex M3, Cortex M4, Cortex M7. For STM32H7 series, it can running on 520 megahertz, very, very fast. Then also SOPC. SOPC technology is a programmable system on chip, which is a flexible and efficient SoC solution proposed by Auto company. Right now, Auto company is purchased by Intel company, so the name have changed. It integrates processor, memory, bus and bus controller, I/O port, DSP, face locked, PLL, face lock loop is PLL. What is PLL? I can increase the frequency. For example, you installed crystal outside, it's only, for example, 8 megahertz, but you can increase it to several hundred hertz. So this is PLL. So FPGA include all this kind of device inside its body, inside the chip. It has a flexible design mode, which can be cut, expanded, updated, and has a function of software and hardware in system program. So in the advanced course of our training, you will learn how to use FPGA to design a product. I have contract with some Taiwan company. They want to, in nowadays, some sensor they cannot buy. In the past, one sensor is about 100 RMB, but right now it's 30,000 RMB. So not only very expensive, but also they cannot, it's very rare on the market. So I design PCB board for them. Use FPGA to simulate those older PCB board. Then the PCB board connect with the main board. The main board, the new PCB board cheat the main board. The main board think it's old PCB board, so it can function correctly. So you should have to keep the signal style and the signal series is completely same as the previous older PCB board. So FPGA is used in this kind of device. However, FPGA is relatively expensive. Sometimes it's used in missile. I think Russia is impossible to buy the FPGA right now. You can use the FPGA on missile, on weapon, on some expensive device. So we use FPGA. So evolution of embedded system. Single board computer in the past is Z80, Motorola. You can find this kind of device in some older machine. And also later is a single chip microcomputer like MCS 51. And then this is about before 1990s. This is before 2000. This is after 2000. ARM processor is emerged after 2000. Have a lot of stage. The first very simple ARM processor, LPC, produced by Philip company, later changed to NXP company, NXP. Then at that period also Samsung, then later STM32, F0, and F1, F4, F7, and also ROC chip and TI chip. So a lot of, but the most popular chip is STM32 right now. This is the most popular. Many students learned this kind of processor. So in China market, you can find many chips. Although some chip, for example, TI ARM processor, you can find on the market, but it's very expensive. And compare with the STM32 or other chips, their quantity is very little. You can search on United States electronic like a digit key. You can find that their stock is empty. They also haven't. You can't buy on the United States. They can't buy it themselves. So we have to select some chip which is affordable, mass produced in the market. Not those chip you can't find. If you select those chip already outdated, you can't find on the market, the product is a fail. The project is failed. So you can't select that kind of chip. Another important is that the chip must, the price is in the scope of your limitation, your cost limitation. It's very important. And later is CPLD and FPGA. But I'm not saying CPLD and FPGA is more advanced than ARM processor. These are parallel. These two ports are parallel. Sometimes we use CPLD and FPGA. However, CPLD and FPGA is, especially from last year, almost very, very expensive on the market. So unless you have to select, in general, I will not select FPGA and CPLD because it's too expensive compared with general purpose ARM processor.
Recording stopped.
差不多了吧，时间？那么下一次吧，其他的。
你说收尾了
啊？
说收尾。
Recording in progress.
下一次讲什么？下一次？
下次吧，继续讲下去，然后再讲那个开发了。Okay. Today the time is reached, and next time I will continue this introduction. However, we will begin. I will teach you begin to design the first product, electrical humidifier, electronic humidifier. I will introduce the later, like this device. However, before I introduce the electronic this humidifier, how to design this humidifier, I will give you some material, and I also will teach you how to design PCB board, how to design schematic, how to design the product from the requirement or from the market investigation. I will teach you how to investigate a proper product from the eBay or from the Taobao China. You can find a product very popular, sell a lot of sale number. Then you can target that kind of product. Oh, it's a good product. I will produce this kind of product. Then you, based on this product, target product, you can scope your cost limitation. You can analyze the price, sales price. You can determine your cost. And then based on this cost, you can select a different component. Based on this cost limitation, you should give you solution to how to design the schematic, how to design the PCB board to fulfill the requirement of stability and the cost requirement. And later, we will learn how to submit all this material to the PCB board factory and SMT factory. And through their ERP system, you can get what your sample product. And after your testing, debugging, you can finish your prototype. And you also will have a chance to sell on the market. Okay, today is our class. It's over. And our school will give you a web station. All the material I put on our teaching web station. You can download those material later. If you have some question, you can also ask. And later, there are some, here is our graduate student, Liu Liangcheng. He will responsible for, he is a teacher assistant and will responsible for the, your homework or something. He will do some assistant job. Yeah. Okay.
Okay.